Hey y'all, my name is Chris Stingline, and today I'm going to be presenting to y'all metallic and non-metallic minerals. Examples of them, just kind of the basics. All right, let's begin. All right, so first off, we're going to talk about metallic minerals. So what exactly are they? All right, well, the basic definition of a metallic mineral is metallic minerals have metal in their raw form. So when they're found and discovered, they have metals within them, metal elements to be exact. Where are these found? These are found in igneous and metamorphic rocks, and usually they're deeper in the ground than non-metallic minerals, but they can still be on the top of the surface as we can see. Characteristics of these include they are good conductors of heat and electricity. Um, they're usually pretty hard. They have their own luster, which is a good characteristic if you're trying to figure it out, like in one of our labs, if you're trying to figure out if it's a metallic mineral or a non-metallic mineral. And when they're melted down, they leave behind the metal. So all the other stuff the gunk kind of goes away, and they leave behind they leave behind metals. All right, so there's some good examples, and on the screen you can see, but some other good examples. I mean, there's a bunch. So I mean, iron, gold, silver, platinum, aluminum, tin, zinc. I mean, the list can keep going and going. So I mean, those are some good basics of examples of those. All right, next up we have non-metallic minerals. Non-metallic minerals, as you could probably have guessed, they're minerals that do not contain any sort of metallic mineral within them. Where are they found? Okay, so these are found in sedimentary rocks most of the time, or actually all the time. They're found in sedimentary rocks. Characteristics of these include they're not so good at conducting heat or electricity. They're wide ranging in terms of hardness. Um, they don't have any luster. And when they're melted down, they don't really leave anything behind. Some good examples of these include limestone, granite, salt, gypsum, micas, etc., etc. The list could keep going. So now that you kind of know the basics between both of these, we can do a little bit of a comparison. So you can see on the screen, there's not many similarities because I mean these are basically the opposites of one another. So as stated before, metallic minerals have metals in their rawest form. However, nonmetallics do not. Metallic minerals are found in igneous and metamorphic rocks, whereas nonmetallic are usually found in sedimentary rocks and actually young fold mountains. So, I mean, they are within mountains sometimes. Metallic minerals are good at conducting heat and electricity, whereas nonmetallics are not. Metallics, they have luster, as stated before. That's how a good key difference when you're trying to determine whether a mineral that you're looking at is a metallic mineral or a non-metallic mineral. Metallic minerals, another really key difference that I haven't really talked about yet is metallic minerals, let's say you're constantly hammering on it, they're not usually going to break all the way down. Like when you get to the metal within it, it's not going to be able to keep getting smashed. However, if you're going to keep pounding on a non-metallic mineral, then that will usually break down and leave kind of nothing into tiny little pieces. So there y'all go. I mean, that's a basic rundown on metallic versus non-metallic minerals.